Okay, we are live. So welcome everyone. Thanks for joining us tonight. My name is Dieter Borman with Central Plateau Cleanup Company. Bear with us, folks who are here in person. Thank you so much for coming. We also have folks online. So I'm gonna be going back and forth tonight. And this little device here called the Owl is picking me up visually and audibly. So we're kind of stuck in this place here. I want to go back real quick about last 20 months ago. The last public meeting we had here in the Richland Library was on January 21st, 2020. And little do we know then, right, how our world was about to change. So it is good to be back after all that time away. It's good to see people in person again. And of course, we are in the world, and we're going to continue to have a virtual option for folks who can join us wherever they might be. So,
can people to mute?
Yes, if you are online or on the phone, and we'd ask that you please mute your phone and your devices unless you're asking a question here, and we'll get to that shortly. We're going to be talking tonight about a permit modification for the waste encapsulation and storage facility out on the Hanford site. I will let Dwayne Carter here explain in more detail what those changes entail here in a second. Again, thanks for being here. Any questions before we get started here? I think we have a agenda here up on the screen, and for folks at home, I believe it's on your screen as well. We're going to go through a presentation, and then we will have a chance, should have plenty of time for Q&A. Yes, sir.
Can you check those lights off there's a
They're glare here. Jen, can you?
glare.
Yeah, we can do that. I think so, yeah, so this is screen a little better. Folks at home, can you give a thumbs up in the chat if you can? Just want to make sure everyone can hear me okay. And again, for you online, we're going to be using that chat function on Teams. So feel free to put your questions in there. We can either ask them here in the room, or when we get to the Q&A session, you can feel free to ask them yourself. So we have some flexibility there. Okay, I think without further ado, Dwayne, if I'll let you take center stage here.
Thanks, Dieter.
Can you hear me? Right on? Okay. So. All right, as Dieter said, I'm Dwayne Carter. I'm a physical scientist with the Environmental Compliance Division for the Department of Energy. It says here Richland Operations Office, but I also do work for Office of River Protection and the Pacific Northwest Site Office. So I work for all three field offices. This is going to be a proposed permit modification for the waste encapsulation and storage facility. I'll refer to as WESA from now on. That's what you'll hear it called. So next slide. Everything's falling. It's all right. You got the slide thing? Okay. So this meets the Washington Administrative Code regulatory requirements for public involvement, and that's section 830 of 173.3. To inform the public on the proposed waste encapsulation and storage facility, and as I said, WESA Class 2 permit modification request for a Hanford facility dangerous waste permit. Next slide. So WESA is located in the 2 east section of the facility, also called the Central Plateau. It is just right off of B Plant, which is one of the canyon facilities out on site. And for reference, it would be just west of Purex site, which is the other canyon in 2 east. Next slide, please. So Wessup was constructed in 1973, so it's pretty much it's lived its design life by now. From 1974 to 85, radioactive cesium and strontium recovered from Hanford's waste tanks were placed in stainless steel capsules and stored in concrete fuel cells in Wessup, where they remain today. So the form that the cesium is, it's cesium chloride, and the strontium is in strontium fluoride, so they are dry salts, basically. The 1,936 capsules are stored in the water in the pool cells to protect workers from radioactivity and help keep the capsules cool. Now that the cesium strontium has passed the half-life of about 30 years, so you don't get this bright blue glow in the pool cells anymore, the capsules are in a safer state to move from wet to dry storage. Work is underway to transfer the capsules to dry cask and then move them to the nearby dry storage area. So that capsule storage area or capsule interim storage has already been built. And so we're doing the modifications to Wessup right now. What this permit mod does, next slide. It'll increase hot cell G. So there used to be hot cells A through F, and during the inner enclosure activity, hot cells A through F were graded. So there's only one hot cell left in Wessup, and that's hot cell G. G cells used to stage and load the capsules into universal capsule sleeves, also referred to as UCS, before they are transferred to specially designed casks for safe transport to the nearby dry storage area. So this cask meet the Nuclear Regulatory Commission standard for storage of radioactive waste. It's the same thing you see out at Columbia Generating Station for spent fuel. So next slide. So here's the basic design. You got the pool cells right here. So that's where about 10 feet of water, your capsules are right down here. So what will end up happening is they'll get transferred to G cell and moved over to the truck port via the canyon, above the canyon. And then a truck port's being modified right now to store the casks. It'll be loaded, the UCSs, the universal capsule sleeves, into the cask, and then it'll be transferred west about a mile to the capsule storage area. So what, next slide, please. What this permit mod is proposing, it's a class 2 permit mod, which requires a 60-day public comment period, updates to the part A, and that's your initial permit application material, and addendum C, process information. This will increase the storage capacity of G cell. Addendum C, to discuss the process for safely managing the capsules during transfer activities, and updates to addendum G, personnel training, to include new personnel positions and associated qualifications. Next slide. So currently, hot cell G is permitted to store 9 capsules. So we're going to increase the capacity of G cell from 9 to 14 capsules. So a universal capsule sleeve holds 6 capsules. So basically what this modification does is gives us the ability to hold 2 UCSs in hot cell G. And there's a picture coming up, the upender and the other storage place and a buffer area. So that'll give us 14 capsules. What this does is, in case something such as the cast trolley breaks down, we have to get a new trolley, we can't move. It gives us the ability to store up to 14 capsules in that facility. Like if we have to do maintenance on transport over to the truck port, this is majorly for a contingency. So typically we'll not store more than 9 capsules. But that this gives us the ability to. I just walked through the 2 storage capsules. Next slide, please. So this is the upender and the recovery shield assembly inside hot cell G, and that's how we'll load the capsules into the casks and then have a recovery shield assembly in case we need to have shielding. So next slide, please. So as part of the permit modification process, this is 60-day public comment period on the proposed Wessup Class 2. Submit comments electronically, which is a preferred method, into the websites listed right there. It's also on Hanford.gov, or you can mail them to Dana McFadden at the Port of Benton Office for Ecology. Next slide. So like I said, this is a pretty straightforward permit modification, upgrading hot cell G's capacity from 9 to 14 capsules. And it typically would not go more than 9, but it gives us the ability to store 2 universal capsule sleeves and 2 other capsules in case we need to, such as maintenance activities or any other potential contingency. So that's all I have. I can take a question now.
Yeah, thank you, Dwayne. So we got, everyone's in the frame here. Okay. I want to recognize real quick, don't want to put ecology on the spot here, but we have some representatives from the Washington Department of Ecology in the audience. Ecology is the regulatory authority for the Westwood facility and this permit modification. So if there are any questions from a regulatory perspective, these gentlemen may be able to answer those questions. So this meeting is scheduled until 6:30, so should have plenty of time for Q&A. Why don't we just go ahead and jump in if there are any questions for Dwayne, both here live or online. Yeah, go ahead, sir.
You know, it says, for safe interim storage. Why don't you do it right the first time or do it one time only and move it to permanent storage? You never told us what permanent storage is. This is just an interim step, right?
And I think that references to the capsule storage.
The capsule
Site.
interim storage area, that's correct. Currently, we don't have a repository for the cesium strontium capsules. Interim's a term used by the Department of Energy. It's basically a long-term storage, and it places the capsules in safer configuration than they are in the pool cells right now. Like I said, the pool cells they've had their design lives, so and we've gone through a half-life of cesium and strontium, so it's safer to put them out on the casks. And this is the same type cask that, like I said, is used by Columbia Generating Station for their spent fuel. It meets the NRC requirements, and you'll see most of your nuclear power plants have these casks. So yeah, it would be nice if we had a repository to take them to.
So the permanent storage would be something like Yucca Mountain. That would put,
If they ever put Yucca Mountain back online, it was taken offline during, I think 3 administrations ago.
that would be its final resting place, something like Yucca Mountain.
Correct.
Any other questions here in the audience for you?
My name is Rob Davis. I'm with the app. I represent the city of Pasco. Yeah, I think this gentleman over here did bring up the final disposition for that waste was to be included in a high-level waste melter. Okay, and to immobilize it and to then send it to the national repository. So immobilization is going to be very important. The crystals, the chloride crystals, are not in an immobilized form. They're in a capsule. Okay, I came here to ask certain questions. One is, what is the consistency between capsule to capsule to capsule of all 1900? Are they, some are strontium and some are cesium? Have you done calorimetry on them? Do you know what the decay heat is other than through some sort of calculation? To my knowledge, you haven't measured the decay heat. And the other thing is that I believe the permit is straightforward. You know, it's very logical. You need more space, you need to do it, and to go this path. We've decided to go this path. But I would hope ecology would ask the questions of what's the failure scenarios of this process. Okay, and there may be several in there that would involve using G-cell to rectify something. Is that correct? I mean, are you going to keep that facility operational? capsule breaking, capsule, gas leaking out, losing its thermal conductivity, overheating. Are these scenarios in your accident list? And if they are, where is this accident list? Because I don't think we've seen it.
I don't know about the accident list, but hot cell G is specifically to do exactly what you're talking about. If we do have an issue on the capsules, we have overpacks for the capsules and we can overpack them. We already have some of the capsules that had seen bulging or some issues, and those have all been overpacked. So that would be the best case scenario. And hot cell G is designed to do that. And that's what the shielded assembly was for, if we do have that issue with the capsule.
So then do we have leakers?
Not right now. Everything's that we had an issue with the capsule. We saw any bulging, it was overpacked. And if you did have a leaker, you would note it because we do monitor for rad in the pool cells.
Right. Yeah. Jeopardies, yeah. They're very soluble, those cells.
Correct.
Anyway, I would hope ecology would have, I2RPD, take a look at the plan and have independent engineering reviews and other than that, those are my questions,
Right. And
basically.
once we get all the modifications done to WESA to include hot cell G, the transfer to the truck port, we will have an IQRP and qualified registered professional engineer come in and do that assessment. So every time you do a construction event or a modification event, it has to be certified by an IQRP.
Right, I understand it, but it looks like increasing the number of capsules is purely administrative. I mean.
Yes,
Yes.
that's correct.
And those are not construction related and
but we are doing modifications to hot cell G, which will be certified at the end.
okay. And calorimetry, I mean, how are we guessing if they hate you?
I have to defer to one of our nuclear groups. Is it, like I said, they're under 10 feet of water, and the only test they really do on them is the clunk test, where they pull those capsules out, clunk, and make sure that it's not bulging and stuck inside the capsules. So, and the only measurements for temperature are just of the room and the water.
Right, it's not so much the temperature, it's the decay heat. And so what you're saying is one half-life, so you've degraded the specific activity, right? But you're still decaying.
Correct.
I want to mention too, that this meeting tonight is being held in conjunction with a public comment period that runs through September 4th. So any questions that don't get answered here tonight, if you'd like to put them in writing, send them. They will go to ecology where they will be addressed in a Q&A there. So,
And if you have that specific question, if you could write it down, I'll have my nuclear group look at it.
Sure.
Because we have some pretty good nuclear physicists on staff.
Oh, yeah.
let's get to our folks on Teams tonight online. Any questions? Any questions on the chat for Teams?
Dan Solitz has a question.
Okay, Dan, would you like to ask your question?
Yes,
Go
thank
ahead.
you. Yes, I would. I understand that the need for a surge capacity makes a lot of sense. I'm just kind of curious how much time that gives you. How long does it take to load a cask?
Can I defer that question to my two federal engineers in the back, Gary Piles and Jack Conley?
Yeah, so right now, the assumption is that it'll take about a month and a half to load a cask. There's some uncertainty, right? There's still some uncertainty with that. Obviously, we are working to get a mock-up up and running. That'll allow us to to start developing procedures, training, practice upset conditions, and operations, so that we're truly proficient before we start working with these highly radioactive capsules. So as we get into that, we'll have a little bit more detail, exact timing and process for how long it will take to load these capsules. But right now, our assumption is about a month and a half.
Okay, thank you. And I have another question on the lead capsule project that Nuclear Waste Transportation, Nuclear Waste Technical Review Board is asking you to do, to have a couple of empty casts, or maybe one empty cast that sort of evaluate its natural aging on site, just to see how it does. Have you got any information on that, or is that out of the purview of this meeting?
I don't know, I don't have all the details, but yes, we do have, we purchased 19 casts, 18 casts we will be using, loading and putting on the capsule storage pad. And then with the 19th cast, we're going to be developing an aging management process that will be able to, like I said, kind of evaluate the cask over time to see how it ages and how it reacts with in the environment, things like that. And I think we're working with Peanut and L and other commercial companies that deal with the NRC spent nuclear fuel cast to try to kind of do some lessons learned for them as well.
Okay, thank you.
Thanks for those questions, Dan. Anyone else on Teams? have a
Yeah,
question?
Jan Cantrell. I have
Jan?
those.
Jan, go ahead.
Can you hear me? I just took myself off mute.
And thanks for joining us.
Yeah, can you hear me?
We can hear you.
Great. I had the opportunity to get inside the WESA facility during one of our tours. And also I remember that we had someone come in to speak with us about the overpack or the casks. I'm not sure what the terminology is for where these are, there's like 6 or 8 of them inside of an overpack that's going to be in dry storage. So my question really is, I was under the impression that the Department of Ecology didn't really have anything to do with radioactive waste. And why is it that Ecology is the lead agency for this project?
That would be, ecology regulates the mixed waste portions of the waste. They do not regulate the cesium or the strontium. It's just the miscellaneous metals and stuff that came from processing. So they regulate the mixed waste.
But there are radioactive elements in the casks, right?
Correct. That is the definition of mixed waste. It's radioactive and hazardous.
And so it's kind of at its half-life right now.
It's reached a half-life, correct.
So that was how many years, like 30 years or something?
Pretty give or take.
So over time, it'll become less radioactive, but it will still be in dry storage for, an indeterminate period. Is that correct?
That's correct.
So will there be any need for it to go to long-term storage underground as it becomes less and less radioactive?
Yes, eventually if we could get a repository or space open at WIP, we could do that. But right now does not meet WIP's waste acceptance criteria.
Oh, eventually it could go to WIP.
Decades and decades from now.
Yeah, well, thank you very much.
Thanks, Jan. We'll go back to our live audience, Ed.
Eddie Holbrook, Department of Ecology. The dynamics of this meeting are really different, and you kind of wait for your cue when you get called, for an answer. And I wanted to answer your question, sir, regarding the, which you had referred to regarding the accident list. So any release from a container, in this case, which are the capsules, would be covered under our contingency plan and preparedness and prevention addenda under the permit. And a release from a container is covered under those documents. So I just wanted to answer that question. But if you do have any further questions regarding the release of materials, especially in the case of the transfer that would happen down the road, feel free to make that comment, and we'll certainly answer it as needed.
Thank you. Anybody else? Good.
I need a basic, question. It seems to me like cesium and strontium are valuable to somebody. And here we are taking a valuable resource paid for by the taxpayers, and we're putting it in another capsule. It's letting it sit on the top of the ground until it completely decays. Can we do something with cesium, strontium to make it useful for something?
We did once upon a time use it for like medical irradiation, but we had an issue long before my time here at Hanford, where it was down in Georgia and they did some temperature fluxing on one of the capsules and bulged it, and that's the last time we've shipped cesium or strontium capsules off for medical irradiation. And yes, cesium can be used for medical use.
So we learned from that, but, it's like having an accident in the space program. You recover from it and you keep going forward, and you could do something to, help mankind with all this nice cesium and strontium we have. I just think it's a valuable resource that's being wasted.
Like I said, once we had that issue down in Georgia, with the temperature fluctuation and the bulging capsule, that's the last time we used it for medical irradiation. And yes, cesium is valuable, and I don't know if you know about the Harborview event that happened here last year. Yeah, last year, where they cut into a piece of equipment that had cesium, so they had a cesium release. So they had to shut down Harborview, and that cesium actually went out to our 325 RPM lab, and we did reuse that. That was sent down to Texas for reuse. But yet, this isn't as pure a form as that cesium as the released at Harborview.
Thanks for the question. Good comment.
Thank you.
Someone else online?
Mia Burke is in the queue.
Okay, yeah, Mia, go ahead.
Hi, yeah, thank you. I'm wondering if there are any plans to delay the transfer of the capsules to dry storage. In the latest WESIF inspection report, Derek Klein confirmed that they have not filled any cask storage systems yet, and they continue to work on preparations and testing. And Derek Klein also mentioned that USDOE would be coordinating with Ecology to modify their milestone due date of August 31st, 2025. So do you have any more information on that?
We are doing the modifications right now, getting all the casks built right now. We just got some of the universal capsule sleeves in. And then, as Gary Piles mentioned earlier, we'll have to do training, get the operation up and ready. We do have a mock-up facility out at the maintenance and storage facility. That's the one out by FFTF, Fast Flux Test Facility, that we are getting ready to train operators on. So we're not delaying, we're just proceeding basically at a good pace. So I don't know about the milestone. Derek Klein, would you like to mention the milestone? Derek is here.
You can hear me okay then? So basically with COVID impacts, supply chain impacts, things like that, we are potentially going to miss that milestone. We have informed Ecology of this, and in discussions back and forth, we have decided that we're going to essentially wait until we have the mock-up up and going so we can do some of our time and movement studies to kind of figure out how long loading operations will take. And then once we have a better idea of how long the loading operations will take, we plan on going through and renegotiating where that milestone will be moved to. As of now, it's probably about a year or so schedule slip. But again, we'll know a lot more as we start to finalize a lot of our time and movement studies with the mock-up and developing procedures and actually getting workers out there to play around with all of the test equipment. Does that answer your question?
Yeah, thank you very much. I appreciate your answer. Can I ask another question as well?
Go ahead.
Okay, so how much money is needed to fund WESIF to get the project done on time? We noticed in the TPA budget overview presentation from June 2022 that the funding for WESIF modifications and capsule storage drops to 3.1 million for FY 2023 under the president's budget. And that seems to us like a steep decline from the FY 2022 enacted budget of 8 million for WESIF. Can someone please explain the funding needs for this project?
So to answer your first question, there's not really any amount of money we can throw at this to hit the milestone, just because it's a lot of supply chain issues we're seeing with vendors that are causing the delays, and there's not really a good way to recover from that. We have looked at various discussions on going to overtime shifts during operations. You increase your risk when you have more shifts, so that's something that we have considered, but aren't really don't really want to if we don't have to.
Yeah, this is Gary. So I'm not sure where the dollars are going. The 3.1, I believe, is what we've requested for next year for just the line item portion of the project. So again, the capsule dry storage projects are kind of split up into 4 sub projects, if you will. And so the line item, that 3.1, I believe, is for the line item. That's all we need to make the total project possible, because we already have money that we have received previously from previous years. And so we have enough money to fully fund that project, as well as all the other portions of it. So that's the only, like I say, that's from the 3.1 million that you mentioned. Again, I think that is just money that goes directly towards the line item, and that's the last bit that we need that completely funds that portion of the project.
Okay, great. Thank you so much.
Thanks, Mia.
It looks like Jan Cottrell has a question.
Okay, Jan, you have another question for us? Jan, go ahead. I think you're still on mute. If you have another question, go ahead. Any further questions here in the audience? Yes, go ahead.
What was the impetus that requires you to move these capsules? What's the reason why you're doing it? Apparently it says you're gonna save 6 million in annual operating costs. That's a factor, I suppose. But what's the main one?
Sure.
What's causing you to move this?
Yeah, good question.
Why not just leave it alone?
So the capsules have been stored in the pool cells since the 70s. The pool cells are at their design life, and the capsules represent a third of the major risk in Hanford. So if we get a leak from the pool cells, we could release to environment. Taking them out into dry storage, which is typical for a nuclear facility, puts them in a safer configuration. And yes, the operating costs do go down because it's mainly just ambient temperature out in the field. We get rid of WESIF, get rid of maintenance of the pool cells, maintenance on all of WESIF, because WESIF is also with the pool cells, the aging structure.
So the water in the pool cells are radioactive, and you don't want that getting out in the environment. That's probably the main impetus.
If we have an issue like that, but no, the water is pretty much clean. It's irradiated because it's coming from the shielded cesium strontium. Gary, do you have an answer?
Yeah. So just a little more information on this. There's really kind of 3 big drivers for this project. One, like Dwayne mentioned, is just the fact that they're in an aging facility and maintenance costs continues to increase each year. So on average, we spend about $8 million to maintain that facility. And so when we put them in dry storage, that cost will go down significantly. And so we'll see a huge cost saving there. But the other 2, one is associated with the Fukushima event that occurred back in 2010. Shortly after that, DOE did an evaluation of all its nuclear facilities to determine what would be the impact if we had a beyond design event were to occur. And Wesson was identified as one of the highest risk, on-site risk, because of the amount of inventory that they have that is in the pool cell. As Dwayne said, about a third of all the cesium strontium that's on the Hanford site is located at Wesson. And then the other reason is there was a lot of concerns with the degradation of the concrete because of the exposure that it was being, that it was getting because of the high dose of the capsules. And so there was a lot of concern with how that's impacting the concrete within the pool cells. And so there's been studies that saying that it is safe, there's still a concern there. And so for those three reasons is what will kind of push the DOE to start this project, to put them from a pool, from the pool cell into a dry storage configuration.
Thank you.
Good question. Yeah, go ahead.
Near as I can tell, you're talking about 10 half-lives is usually the rule of thumb. So we're talking about storage in these capsules for over 300 years. My question is this going to get turned over to LTA, long-term storage activities, and how will it be funded? And, are we looking at what it's going to be down the road once you get them all on there? Long-term storage or something?
Gary, do you have the timeline on that?
So I think as Dwayne mentioned earlier, right now, there is no disposition path for these. Ideally, these would be somehow either placed or go to the bit plant and immobilize that way, or sent directly to a repository as is, once that option becomes available. So for right now, there is no disposition path. And so right now, we're just looking at, like I said, interim, long-term storage. Right now, the casks are designed for 40 years storage expectancy, but that's why we're doing the aging management program, so that we can then defend storing for longer if and as needed. And as you said, they continue to, over time, continue to go through half-life, and pretty soon it would be, less radioactive. But, again, we don't know how long they're going to be out there, but we're trying to plan ahead, look ahead as much as we can.
Let's stay here in the room. Any?
How hot do these storage facilities get when they're sitting on the concrete pad outside? Does the wind take the heat away?
The casks?
Yeah.
There is a passive cooling system. So yeah, it's basically just
Just the wind blowing? Okay. Do you?
they will have thermocouples hooked up to them, so we will be able to monitor the temperatures.
Do you coordinate with, it seems to me Energy Northwest stores spent fuel on a cask out in the open also. Do you coordinate with them to learn what their pluses and minuses are?
We have had engineers and scientists go out there, and now Energy Northwest is our tenant, so they lease the land from DOE. But yeah, it's a similar system to any other nuclear reactor where you store them in cask outside.
Let's go back to our online audience.
Yeah, Liz Matheson typed a comment. She asked, just to clarify, is the potential schedule slip a supply chain issue?
As Derek had mentioned, it's a mixture. The pandemic impacted us, and you saw throughout industry all the supply chain issues we had, especially like the major ports being backed up for weeks. So yeah, it's an issue throughout industry. So yes, that is part of the supply chain issue.
All right, thanks for that question, Liz.
And next in the queue is Mia Burke.
Okay, Mia, you're up again.
Hey, thank you. Are there any plans to test the concrete after the capsules are moved to dry storage so that the data can be used to better understand the impacts of radiation on the strength of concrete?
That's the concrete in the pool cell.
Yeah, that's correct.
We will end up, once we get all 1,936 capsules out, we will end up demolishing Wesif. So there will be some sampling. I don't know if there's specific sampling for that concrete because we're predisposing of it. So I would leave that up to the projects and the engineers if they want to test the concrete.
Did you have another question, Mia? Oh, you have the floor?
I think that's it for now. Thank you.
Thanks.
The next person in the queue is Jerry Paulette.
Okay, Jerry Paulette, you're up.
Thank you. I'm extremely concerned about the delay. How long did you say the delay would be?
I
And
think it was
comparing
stated that we're still evaluating that.
So would you, the delay is from the projected start date rather than the TPA milestone, which was August 2025, is that correct? And how much slippage? You're still,
Yeah, Derek or Garrett, do you want to restate that?
Yeah, so our critical path for this particular project is the fabrication and installation of both the test equipment that will go into NASA, as well as the production equipment that will go into West. And so during COVID, we have seen about an 8-month slip in the fabrication process for just the test articles themselves. And again, a lot of that is with COVID. A lot of the facilities that are working to fabricate this equipment is here in the state of Washington. And so they were impacted by the 3-month shutdown that we saw early on in COVID. And then of course, throughout the fabrication process as beginning, because there's a lot of specialized welder, machinists that are involved with this. Anytime that they were out because of COVID, that had an impact to our schedule. And then, of course, indirectly related to COVID, we've seen a huge impact to supply chains and to a backlog of work from a lot of these facilities that support this project. We have like dozens of vendors across the country as well as across the world that actually support this effort. And so again, they've all had some kind of impacts one way or another, and those are what is impacting our project. And we're continuing, as we start to fabricate production equipment, we're still seeing impacts to those supply chains and those backlog, those facilities as well. So,
I'm sorry I have to keep repeating, but so if it's 8 months, is that 8 months from the TPA milestone, which was August 2025, or is it 8 months from the already delayed start date that had been announced, which I recall commenting on in the 5-year plan, which was in 2026?
So the 8-month is from the TPA date. So this project had very little float in it when that date was negotiated or when we developed the final schedule for the project. And so every delay that we have associated with the fabrication is really kind of almost a day-to-day slip. And so that 8-month is what was reflected in the 2026 date.
Right. And now I want to go back to the seriousness of this. People have asked questions about why remove it. I think it would have been helpful to have a reminder that the safety analysis report for the pools in Wesseff states that the loss of water in a single pool cell creates fatal dose fields and a field of approximately 120 R an hour outside the 225B structure. That's, in other words, in 2 to 3 hours, that would be a fatal dose level outside the structure. And this is in the event of an earthquake, which we know is possible, right? So I think it's really important for people to understand there is no leeway here. We are years behind schedule, and we are gambling that major earthquake doesn't happen between now and 2026. Because if that happens, the safety analysis report says we will lose the water in the pool. And the consequences are catastrophic. They're not minor. And I would just put that out as a reminder to people and about the importance of doing everything possible to get this back on schedule. Thank you.
Thanks, Jerry.
And now, Liz had a additional follow-up question. Do we have time? She wanted to ask.
We do have time. Liz, go ahead.
Thanks, Dieter. It was just about the 40-year expected life for the storage casks. So after that 40 years, would they need to be repacked, or do we know what's the next step after that 40 years?
Get the microphone to Gary here.
Actually, they designed the cast to be much longer than 40 years. I think it was 300 years is what they're designed to. But in our safety-based analysis that we do on site, we only take, right now, we only take credit up to 40 years. And then again, through that aging management program that we have or in place, that'll again just kind of help defend the extending it for our safety basis analysis for the facility. But the casts themselves are actually designed for 300 years.
Did you catch that response, Liz?
Yeah, thank you. I could hear the sound's been great tonight, so thanks.
Good. Any other questions on chat right now? Any more questions on the audience? Is it what time check?
6:20.
6:20. All right. So
We might want to check the phone.
is there anybody just on the phone? Sorry, not on Teams, but just calling in tonight that might have a question. Okay. Anybody else here? Rob?
Yeah, so at the last CAB meeting, when we were getting this presentation, there was quite a bit of discussion about the cover gas, about the gas being used to help convey the heat outside of the rods into the channels so they can be passively cooled. And the question people had was this was helium, correct? That we're using, and yeah, I mean, scientifically, you're right, but doesn't helium also have a price to it? It's very rare now, and it's very expensive. And are you going to have to pressure test these to assure, and how long would that maintenance? I'm getting your next one here. But I'm just thinking that they are going to need some active maintenance, are they not? With having to replace the helium from time to time?
Wayne or Derek?
I brought them two along.
So yeah, there is going to be helium backfill. The amount of helium that goes into these things actually really is not that much, just because there's not a lot of space between the capsules and the aluminum. So it's actually kind of very little helium. As far as needing the helium, they will be leak tested at multiple stages because the universal capsule sleeves will have helium backfilled as well as the transportable storage canister that is going to hold UCSs in the concrete caps. Both those will be backfilled with helium and they both will be leak tested. Will be leak tested like an hour. Then as far as needing helium into the future, if the capsules do eventually leak or the casks do eventually leak the helium out, it's really only for the first 10 or so years, I believe, that the helium is required. After that, if the helium does end up leaking out, the capsules will be cool enough to no longer require that for the heat transfer properties. So realistically, there's not like any kind of maintenance needing to be done to ensure that the helium's still in there after we reach a certain point in time.
So cesium reacts with oxygen in the air, and it's exothermic. And the helium that was being used, will be used in fuel fabrication areas, was simply there to displace the oxygen and prevent those reactions from occurring. Okay, so if the helium's gone, what's going to protect from oxygen and potential leakers? I don't know. It's just a question.
There's not really a lot of space in these capsules. So so essentially you have a whole bunch of defense in depth. So you have the capsule, which is inside another capsule, and then you have the universal capsule sleeves with a few mechanically sealed, and then you have the transportable storage canister, which is going to be welded. So you would need to have multiple leaks just to get oxygen in there. And then on top of that, it will react with oxygen, but there's not really any space in there. It's very little helium. If there was a leak, it would be very little oxygen that would ultimately react with cesium. If all four of the defensive gaps up to there. Right. Then like that really answers it.
Well, it says it was definitely considered.
It's, the cesium is definitely part of work.
Okay, let's go back to our online audience one more time. Any more questions yet? Anyone else have a question online that they want to ask or put in the chat? Okay, and anybody else here, our live audience? Any further questions? Yes, sir.
Say 300 years from now, somebody in the world, the whole world, wants some cesium or strontium, can they retrieve it from?
Yeah.
And use it? Is it usable in 300 years? I don't know if it's
Yeah,
being
see
good to use
See a
it.
nod here in the back, but
Derek's nodding yes.
We have kind of played around with the idea of removing the strontium and cesium from the casks for beneficial use. Just kind of playing around with the possibility, and it is possible. It will be really expensive. There is enough curies out there that even in 100 years, it would still be usable. At that point, what we have to do is get it into a facility and process it down to a concentration by basically removing the decay products out of it. But there's just so many curies out there that even after 300 years, you can definitely get some value out of it. It's just, it will be a significant cost and effort to get it out of the casks once they're in the cask. And then we don't have any facilities really in the US that can really do that right now, so it would probably involve building something. But no, it's things that we've thought about. If someone ever came by and wanted the cesium and strontium, we could eventually get it out and use it.
all right, thank you. Okay, well, I'll just ask one more time. Well, I think we have a couple minutes left. If there are any last questions here.
Yes, Dan Solis, how many people are in the physical audience there? There's what, 16 attendees online?
Yeah, good question, Dan. I was actually going to mention that. We have about a dozen folks here. Yeah. And,
Okay, thank you.
online, so yeah. You know, I'll use that as a jumping off point to mention, the evaluation we have tonight. As I mentioned at the start of the meeting, we're back in person here. It's fantastic to have a live audience again and be back together. And to have both of these opportunities, for folks to join us virtually and in person. We are still kind of working through some of those logistics, so please let us know how that worked for you online, you know, how it worked for you folks here. We do love to hear from you, and we're going to continue to, you know, work on improving the process going forward. So thanks again for joining us. Again, you have an opportunity to comment on this permit modification through September 4th, I believe it is. And those comments go to the Department of Ecology through, is the link still on the folks online, and we're getting it up here. So you can comment through email, through the digital link there, or write them a letter as well. So I also want to thank our presenter tonight, Dwayne Carter. Thank you also to our experts, Gary Pyle, Derek Klein, Eddie Holbrook from Ecology for fielding all those questions, and appreciate the conversation. Thanks again, everyone, and have a great night.
Thanks for coming out.
Thanks a lot.